back. So, as I left you off before, schematic is done. All we have to do now is shift to the PCB design. But before I do that, for the people who do auto routing, this is an extra feature you should take care of. Basically, it's the wire type or net class, meaning when you transfer, if you try to do auto routing inside Eagle, it will route all wires to a default length programmed inside it. So you have to change that length because not all length satisfy your requirements. So to do that, just go to edit and net class. So right now I have the default net class, which has a 0 mil and 0 drill mil and clearance 0 mil. So those are not acceptable for what you are required to do, or if you are designing a PCB that is going to be etched through chemical or CNC machine in a school or a university, it will not work. Maybe if you send this to a board shop, then yeah, but for something indoors, you have to change the dimensions. So instead of width, let's say we'll make it 1 millimeter. Okay. Defaults to millimeters by itself. What else? Yeah, drill hole. Drill hole is the size of the drill hole for the via. For example, if you are doing double-sided PCBs and you're having one trace going from bottom layer to top layer or from top layer to bottom layer, it will use a via. So the auto router has to know what is the via, the drill for the via size is going to be. Usually if you make it 0.8, it's enough for a drill bit of 0.8 mm, and clearance, it's just the how much distance is tolerated between two traces on the PCB. So if you have two traces on the PCB next to each other, what is the maximum distance you will allow them to be in each minimum distance you will allow for them to be in each near each other? In my case, in our CNC machine, it has a 0.2 routing cutter, so I'll make it 0.2 mm. Of course, these settings change depending on what type of way you are producing your PCB, whether it's acid or CNC. This is aimed at the CNC machine that we have in our lab, but depends on your requirement, you can change it. Okay, so this is the default net class. I will add another class, and call it motor. And motor line. Basically, here it will have the same drill via and the same clearance, but the width has to go up. So I'll say it's 1.2 mm maybe, because you are that trace, the lines, the copper wires that are leading into the motor, usually they will be what you say, carrying a lot of current. So the smaller the trace, the worse it is going to be. So you have to keep it at, sorry, yeah, you have to increase that trace so it can handle the amount of current passing through that trace. And also I'll add another one, I'll call it power. And this one, if you guessed it, this is for the power supply. So anything carrying a VCC or ground, this is going to be the trace for that line. So this one I'll make it 1.5 mm. You can make it larger. I am using this as the bare minimum because I don't want my PCB to be big. So 0.5 mm. Oh, sorry, 0.8 mm, and finally 0.2 mm. Now, what this dot means is that this will be the default type of cable you draw on the schematic. So for example, if I draw a new cable right now, for example, press OK, and then draw this cable like this, end it, and then right click on it, check its properties. I found out it belongs to the motor line net class. So you pick which one you want to be default while you are routing on. So I basically make the default one, which is the 1 mm, which is carrying data line, data information. So there is not a lot of current passing through it. And then the VCC and the motor lines I just modify by myself, straightforward. So right now, anything, all the lines right now are defaulted to default, because I routed in the beginning using the default connection, default net class. So I have to go do some changes for the ones that I don't want them to be in the default class. For example, the 3.3 VCC, this is a power source, so it has to become from the net class of power. So now it's a net class of power. So anything 3.3 has become a net class of power. Right click here, let's check. Yep, net class power. Also the same goes for ground. So net properties, net class power. Also goes for here. So this one, properties, net class power. And yeah, so all grounds are done. Now for the motors, straightforward, go right click, properties, motor line, because this in the end is connected to the H bridge, which is connecting to the motor line. Right click, properties, motor line, and properties, motor line, and properties, motor line. Okay, so GPIOs yeah, GPIOs are just carrying data bits, so there's not a lot of power passing through them, so I will keep them at the default value. And this resistor and diode and LED is the same case, so leave them at that. So we're done with this. Save your design. I've already saved it. It will ask you to select a name, so save it as whatever you want. And after you are done, go to this one, generate or switch to board. So it will tell you want to generate. There is no what you say, breadboard file for this schematic. Do you want to create one? Yes, of course. So this is your schema board, layout board right now. Keep in mind, since this is the freeware version of Eagle, you get a maximum dimension of 10 centimeters by 10 centimeters. Any more than that, you will have to purchase the Eagle license for a bigger dimension. But this is more than enough than what you need. So we start now by laying the components on the board and how you say seeing how we want them to be laid on the board. So for example, I'll move the Raspberry Pi header, for example, let's say here for the time being. Okay, the motor one here. You just if you click on the center, the plus sign in the figure, you will be able to move it around since you have already the move command selected, and you rotate it using the right click, place them next to each other, doesn't matter. Power, I will say power comes from this side. Chip, let's say I will place the chip right here. And finally, we'll have to move the caps around and everything else. So let's see, C1 and C2 were probably for the motors, so I'll move them here. I know their location, so I should keep them close to whatever they were supposed to work with. So I'll put this one here, this one here. This resistor was supposed to be for the LED, I think. And this is the LED. This is just to show you that the system is on. Okay, and these are the diodes. Okay, I understand. if you try to place something out of the PCB area, he will give you an error. So be careful. Come on. Here, here, here. Just place them in the area for the time being until I work out a better layout for them. Right now the yellow lines show where each head should be connected to. If you right click on it, properties, for example, this wire is supposed to be motor line M2. Okay, so you can know which component is supposed to be connected to what. Of course, this connection right now is a mess. You don't know what is going to what. So to clean this up, you can use this command, which is rat nest, which means it will just redo the wiring again. So let's do it. Yeah, at least you get a better idea. So let's see. So pin 1 is going to be, for this one, this is going to be VCC, and this is going to be ground. So logically you would move this one down and you take this one up, and you would flip, yeah, flip it, why not, rat nest again, it would look better. And what else? Actually, let's take this one like this. Okay. 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 Let's see. Now the connections of the dirt. Oh, see the capacitors. It's crossing. So if you do it like this, it's better. The more you make the wires straight without any crisscross happening between them, the better, because the auto router will not go crazy during the routing process. You make it easier on him, he makes it easier on you. So yeah, let's see. So this is the left hand side. Which diodes correspond to this? So if I go back to the schematic, D2 and D1. Okay, so let's go back to D2 and D1, which correspond to the first output, which is here. So D2 and D1. Okay, it's already becoming big. And then what else? D3, I am assuming, and D4. Let's see, move this one a little bit up, and then D4. So move D4 here. Okay, now we'll take D5 over there. Probably I will have to do some more movements, but let's take it out right now. Just have a general idea where the equipment will be, the components will be laid. So I'll say this one is here, take this a little bit down, this one down. You can actually inch components around. Right now I'm moving it with the mouse and it's moving according to the what you say, the scale that is allowed on the board. If you want to be more accurate, just press the Alt key and it will move in more precision for you. So I think that's enough. Take another diode, and already we don't have space down here, so let's move it out of the way. Let's move these components out of the way. So group all these together, and then right click, move group, move them here. Yeah, okay. Not that pretty. Let's see, put this in the center. Well, this is the price you pay to make sure that your components don't burn. If you don't, your loss. And group again. I hope this is good. This one is not like centered. Okay, this is better. Redo connections again, and what a mess. Okay. Was it D4 and then D3 and line up? Yeah, it was D4 then D3. Oops. Okay, so just move this one up. There's nothing wrong with what I did. The auto router would find a solution, but it would be a horrible solution. So the more you make it easy on the auto router, the more you make it easy on yourself. So okay, I think the same goes here. So this one will go here. Let's use the Alt key to move it around. Okay, and then this would go here. Reroute again. Yeah, it makes more sense like this. So 7 here and 6 here. Okay, reroute again. Yeah, looks good enough. Yeah, so why is this out? Anyway, so let's move these back somewhere better. Move group here. It's already that big, but what am I supposed to do? I can take a longer time and try to minimize it, but time is a luxury that I don't have. So I'm done with this. So all this area, extra area, I don't want to use it. So basically what I can do, I can go to the move command and then select the outboard and then just move it. So my PCB would start and end from till here approximately. Okay, so now it's done. I can start routing. Now I understand auto routing is bad. It's real bad. I know firsthand it's bad. It's not the best way to deal with your connections. Any real engineer would connect one wire at a time by itself. Now, if you are sure of your schematic, you're absolutely sure that everything you did in the schematic is right, you can go ahead with the auto router, but the auto router is not an excuse for not doing it with your own hands. You should do actual routings by yourself. This is an advice, but I will show you how to actually route, and then you can what you say, do it by yourself, or if you choose to do the auto router, you can do the auto router. So how do I do that? Simple. I go to route, and then I have this window here. Any wire I will place, it will be on the bottom layer. It will have width of 0.016 inch. I would prefer to make it 1 mm. You will convert it back to inch, no problem. If there is a via, sorry, it will be either square, circular, or other shape. So I'll choose square, sorry, circle. And then diameter 0.066 inches good, and the drill hole 0.8 mm, not BMM, 8 mm. Okay. Now if I try to route, so I get this blue wire right now from any point. So he's following, if you can see that the blue line is following with the yellow line until you terminate at it. So that's one connection done. If you want to do another connection, you can go here, connect, and voila, your connection is done. Now, for example, if you want to do from this side to this side, but you want to do it in double layer mode. So for example, you will start your wire here, click the left click to place it constantly there, and then go switch to top layer, which will mean red means you went to the top layer, and then you place it there. You find that Eagle automatically placed what you say uh, via for you over there automatically, okay, because he knows that you switch from the bottom layer to the top layer, so a via has to be placed there. Now this is how you place wires and how you write wires in Eagle without the auto router, okay. If you made a wire and you don't want it, choose the rip up option and then just rip up the wire as you want. Just select the wire, left click on it, and that's it. It rips it up. Now let's try the auto router. First I will try the auto router without any modification. It's not a modification, just a small trick I'd like to use. So first I go here, which is auto route. Let's save. Okay, save and then auto route, and then right now the auto router will route from the top and the bottom layers. So let's start, say okay. Now he's testing. He's done that quick. Okay, so he finished all the routing, but still he has two connections he couldn't be able to do. So this is where you guys come in. You have to do it yourself to fix it. But see, the problem with the auto router is this. The thing thinks that you are have access to a board shop machine that can do whatever PCB you want, was it double layer, triple rail, or whatever. He doesn't know that you are poor university student or a hobbyist. You are just trying to make a simple PCB out of through-hole components. He thinks that you can solder on any layer, which is wrong. So, for example, you can see here he is taking a wire, copper wire, from the top layer at this header, okay, and for example he's taken a wire from the IC to the diode, okay, and taken a red wire from the header. So let me show you something. So screw terminal block. Okay, so this is the terminal block that you will be soldering. As you can see, you can solder it no problem from the bottom, but once you solder it on the bottom, there is no way for your soldering iron to reach and for you to place solder on that place on the top side. You get my drift? You cannot get your solder iron to get in there, place solder, and connect to the copper at the same time. It just won't happen. Either you are having some new tricks that I don't know about, or you don't care. You would destroy the whole plastic just to solder it from the top side. It's a big hassle, and seriously, you don't need to go through that. Also, I can give you another one. So I see. Yeah, same thing. IC sockets. As you can see, you can only solder from the bottom. You cannot solder them from the top unless you have something like this, which we call round pins, which have enough metal exposed at the bottom for your soldering iron to reach and solder. Okay. Now, generally, if you have resistors or diodes or capacitors or LEDs, when you place them inside the PCB, this lead, for example, will go down, and this lead will still be exposed a little bit on the top. So you can apply solder directly on the top layer to the resistor to connect it to the pad which is on the top layer. There's no problem there. But if you have headers, screw terminals, or IC sockets, by header I mean this one, IDE header. Like this here, there is no way you can solder them from the top side. You have to solder them only from the bottom side. They can be soldered, but that means you are working in a factory, which is a luxury that most hobbyists and engineering students don't have. Okay, so keep that in mind when you are working with Eagle. So go back to the design again. So this is rubbish. You are not going to consider this. So Control Z it. So you go back to the beginning. Now let's go back to the auto router and select top layer not available, and let him start with the bottom layer first. As you can see, the ground wires are thick, the data wires are small. Okay, so he's done. So I think he did what he could, but still he could not finish everything. This is where the human mind comes in and tries to fix what the machine couldn't do. For example, this one cannot connect to this one. Well, basically, if you took this wire down here, you would have been able to. So I can just select the move command and move that wire down here. Okay. Let's move it a little bit down so it doesn't touch the resistor leads. Yeah, good. See, problem solved. Could have done this easily, but it chose to make it more troublesome for us. Not top layer, bottom layer. So this connection, I will do it myself. Done. This problem solved. You should try to make your PCB all top layer at the beginning. If you can make a bottom layer, if that works, it's awesome. You're halfway done already. Okay, let's see what other connection he could not make, and probably maybe I can make them for him. So this one, from this point to this point, he could not make it. Uh, Probably because this is ground, and he requires the ground to be thick. For this one, it's not a problem. I'll a little bit violate the rule for this one, just for the sake of quickness. You can fix it yourself later on. Of course, I am over the limit of the PCB, so I will have to extend it just a little bit up. Okay, keeping in mind that the size and considerations are everything kept correctly. Okay, if you are not satisfied with the width and you want to change it, simple. Go to the sign that looks like a wrench and select from it width. What is width? Oh, here it is. So if you select dot dot, sorry, I cannot see this option. It's at the end, and you can enter the width you want. So this is a ground width, so I'll select 1.5 mm. Go take the mouse, hover over it and press the left click. It increases the size of the wire. Oops, no, not this one. As you wanted. Okay, so another connection problem solved. Where else? Well, this one is a quick fix, but this one, it requires me to go to the top layer, so I'll go to the top layer for this one. And the width for the wire this time is going to be 1.2 mm. And then just go from here. Isn't this 1.2 mm? Oh well. Here and here. Yeah. Done. Connection done. What else? Yeah. This one also can be fixed if you go from the top layer down to here and terminate it here. This is done. Okay, what other problems arise already? Okay. One problem at a time. Okay, so this one has to go all the way over here. Okay. I will try another trick, which is after I've done this, I can tell him to do auto routing again for top and bottom, but I still have to show him that no, do not start here, start from another place. So first I have to fix this wire because it's coming in a horrible angle. So rip up this wire, rip it up, place a wire instead of it, and its width is going to be presumably 1 mm. So I'll take this one and connect it here. Okay. What else? Squaring, I don't like it, so I'll fix it. I don't like these edges. I prefer not sharp edges, I don't like them. The more space you give, the better. Okay. This is a horrible way for a connection. Why did they do it like this? They said it's not an intelligent system. It can do so much until you have to intervene and fix the horrible things that it do. Example, this one, no, make it like this. Okay, reconnect again just for me to see. So you're aiming for this connection. Okay, that one can be achieved, but later. I want to make sure I can really do it. My first priority is actually getting the Raspberry Pi pins to reach here. So yeah, trying to solve the labyrinth that is the connection. So first here I'll come, place one wire here, and then tell him I'm going to go to the top layer. Okay, and then exit. The same thing, do it here. And then tell him you're going to go to the top layer. Okay, same thing goes here. So what was it here? Done. Okay, let's try to do auto routing again with the top layer. So auto route and top layer is now available for you. Try it. Okay, what did you do? What did you do? Well, it looks decent what he did. So you see, I forced him not to use these pins. He went ahead, of course, and automatically went and used these pins, which is horrible, and I'm going to change it anyway. If you observe here, this, for example here, these are vias that I had control of and were placed, these via. You see, but here this is a via placed by the auto router. Now the dimension inside the hole is 0.8 mm, but the width of the via is not the same. There is some strange equation inside Eagle that I don't know about. I tried reading about it, but I couldn't reach a conclusion how to control it. I know somebody will scream at me and tell me it's done like this, you idiot, but either way, for this one, there is no other way than just for you to modify it. You have to modify the via width itself. So basically what you have to do, go to the wrench sign and go to diameter and then change diameter. So it's 0.066, press on it, voila, it's changed. While I am here, let's move this another one little bit away from the via. Okay, actually make the via like this. It's more easy for the eye to see. No need for you to square it up so much. Okay, beautiful. Beautiful. Okay, so put this one here, this one here. Now, if you are going to solder the chip on the PCB itself, I would say you are done right now, but no. It's not a good idea to solder the PCB, to solder the chip on the PCB for a simple reason. It might get damaged, so you have to desolder it again, and believe me, desoldering a chip of a PCB, it's pain. So do a little more work, better than banging your head on the wall after it. So I will rip this wire, rip this wire, and rip this wire, and rip this wire. And all I do is go here and choose to make it top layer, bottom layer. Okay, here, and then yeah, place it here. And you tell me, you'll put this X here telling me there is no via, so simple, I'll go here and add my own via. Just make that sure that the dimension of the hole is 0.8 mm, and then enter, and then place it. Alt. If you do rat nest again, you will remove the X. So I'll just add these here just for quickly to solve the problem of any wiring. Okay, done here. Go back to wiring again. So wire terminates here. Problem fixed. Problem fixed. Done here, and then that's it. It's done, dude. Reconnect. Go on, man. It's there. What's your problem? It works, but sometimes I don't know. Yeah, by the way, if you try to delete something and he highlights the wrong thing, just press the right click, you will cycle through them. Whatever connection you want. So, for example, I want to remove this X. Cannot do back annotations. Okay. Delete this one. Okay. And then, what? Place a node on it again. Okay. He just wants me to place it that time. So, move this one here. If this is no need for this wire, I will rip it up. So, rip up this wire. We do calculations. Okay, so everything seems fine. So, just I don't. Oh, sorry. Just move this down again. Here. Yeah, very nice. Yeah, this one. Okay, and what else? Seems fine. Mhm. Now this worked out fine because I only used most of the pins that I used for Raspberry Pi are on the left side, not on the right side in my design. If you are using also pins on the Raspberry Pi's right side, then it's not a good idea to place the header here. So probably you would put the header in the center of the design or a little bit inside the design so you can uh, solder the wires on the right or take wires from the right. That's it. This design is complete and ready for printing. So after you are done, you just have to go to file, print that. Print that's for the guys who are using acid. But for the guys who are doing CNC machines, then you have to go to something called here CAM processor. So go to CAM processor after you save CAM processor, and then file, open, job, open gripper 274X. This will generate the files needed for your CNC machine. One file will not be generated, which is the board outline. This is the board outline right now, so you have to add it. So I will remove the solder stop mask file and add board outline. So where is the board at? And the file extension stops being .sts and it will be OTL, and instead of stop it will be dimensions. Process job, it generates the file, and after that go to open job Xilion. Yes, process job done, and then type in the command window here run drill CFG. So it will be in millimeters, and this is the drill bit that you will need to finish your design. So 0.6, 0.8, 0.81, and so on and so forth. We want to save them here. So if you go to documents, Eagle example, some files that you will need for your CNC machine are sol, which is the soldering side, .otl, which is board outline, DRL and DRD are for the drill holes, and component side is for the top layer. These are the five essential files that you need to do your actual for the CNC machine to work. Maybe for another machine it varies. So as you can see here, this board is solderable. It won't you won't face any problems. The only problem I might have with this board is that the resistor and the capacitor via connections are way too small. I can solve that by simply right clicking on them, properties, open device. This is the capacitor right here with the type, because there are millions of capacitors in this package. So right click on it and then select edit. Actually the package is already opened. Okay, actually increase the size. I can go to the wrench sign, and it's not giving that option. Then go back again here and then edit package. So go to edit package, increase the size here, and go to the wrench and diameter. So increase the diameter, so it will be easier for you to solder, because the more copper on the pad, the easier for you to solder. So save. Of course he will complain, ignore him. Done. Okay, close this. Of course these options do not translate yet here, so you have to right click and choose replace. Takes time to open the library. Okay, to open the right capacitor. I hope I remember which package I took it from. I remember it was from here. So yeah, that's it. Press OK. Yes, I do. Okay, so I have a picker pad 1. So similarly, you would do that to your capacitor, resistor. Look, these dimensions were placed for a board house or a PCB manufacturing factory. You are students or school kids or hobbyists who don't know better, so this is better for you. So the bigger the pad side, the easier for you to solder. The smaller it is, the harder for you to solder, and you will probably ruin the pad in the process. Okay, so the bigger, the easier for you to apply solder on. So with this done, that's the end of the tutorial. I hope you found it useful. If you didn't find it useful, well, there's a lot of other useful videos. I just was requested to do this, so I did it. If you had pain damage to your ears because of my sound, I apologize. Thank you for your time, and that's all. Thank you.